Here we go. Okay, so when we divide polynomials, when we're dividing a polynomial, remember a polynomial is a whole bunch of terms separated by plus signs and minus signs. So this is a 1, 2, 3 term, so that's a trinomial divided by a monomial. Those ones are kind of nice. We can just separate it and divide each term. So, I'm going to zoom in so we can see that better. I'm going to rewrite it and just divide each term by 5ab. So I have 5a squared b divided by 5ab. And then I have 15ab cubed divided by 5ab. And then I have 10a cubed b to the fourth divided by 5ab. And now I'm going to use my exponent rules. Remember my exponent rules from the beginning? And I put them on a note card so we can see. When I'm dividing, what do I do to my exponents? Subtract, that's right. Alright, so here we go. What's 5 divided by 5? 1, perfect. And then I have a squared on top and a on the bottom. 2 a's on top, 1 on the bottom. What's 2 minus 1? A, yeah, perfect. What happens to these? They cancel, so I'm left with a there. And then I have minus 15 divided by 5. Perfect. A's are going to cancel, 2 b's on top. So I'm left with b squared plus 10 divided by 5 is 2. A squared b cubed. Perfect. Okay, let's do another one. So I'm going to divide each one by xy. So I have 6xy squared divided by xy. Minus 3 xy divided by xy. Hi Amanda, I have it right here. I'm sorry. I cleaned out the thing and then I forgot to take it back. Could you do me a favor? Could you take these ones back there and put those back in the folder? Okay, thank you. Yeah, thanks. Sorry, honey. Plus 2x squared y divided by xy. All right, you try it. See if you can simplify it. Did you end up with 6y minus 3 plus 2x? Yeah. Perfect. Does it matter what order we write that guy in? No, it certainly doesn't. Remember, addition and subtraction are commutative, so you can add them and subtract them in any order. Okay? Alright, so we took a trinomial or a polynomial and divided by a monomial and we could just separate it, right? What happens though if that guy is not a monomial? What happens if I'm dividing by something with two terms like this guy? And all of those guys at the bottom of the page. Well, I'm going to show you two methods. The first method is called long division. Yeah, like third grade style long division. Okay, so let's have a refresher on long division. I'm making up a number. Remember that? Sort of, right? You're like, oh dang, lady, get out your calculator, right? Yes, but I now have to remember how to do it with polynomials, so we have to refresh our brains. Alright, so I would look at it and say, okay, how many times does 5 go into 4? It doesn't. So then how many times does 5 go into 46? 9 times. So remember I put a 9 up here. And then you multiply, right? 9 times 5. What do you get? 45. And then we subtract. Oh, some of you do remember. I get a 1, and then I bring down the next number, and then it's 17, right? How many times does 5 go into 17?
3.
It's early. I agree. 3 times 5 is 15, and then we subtract, right? And then I get a 2. And then I bring the 8 down. Woo! It goes all the way down there, though. Okay, how many times does 5 go into 28? 5 times. And then I get 28, or 25. And then I subtract. And then I have to zoom out. And then I bring the 9 down. Okay, how many times does 5 go into 39? 7. Oh, this is good, like, more third grade math. 4, and then I bring the 2 all the way down, right, and then it's 42, and you can't see it, and I still have to scroll up. How many times does 5 go into 42? 8. And then when you were in third grade, you got to do, oh my gosh, you got to do this, right? Big old R with a 2. Right, remember that? Okay, well, then you're like, okay, then you got to 4th grade and they said, add a 0, right? So, remember that? That's what ends up being like that. Damn, it works. I didn't even think, right? I didn't even think that was going to work out.
Wow.
JJ skipped that day in 4th grade because he's like, that doesn't look right.
No, well, I remember they were all like terrible numbers, so I just like have to keep adding zeros.
Right?
Number.
Yeah, like 3, 3, 3, 3. Thanks, like third grade teacher, right? Yeah. That was awful. I made that one up. I'm surprised it worked out. Okay. Anyway, remember that? So we figured out what went into there, then we put it on top, then we multiplied and we subtracted, right? Guess what? We're going to do that same thing with polynomials. And now I got to zoom in. So, yes, you do need to save yourself some room on these bad boys. Alright, so I'm taking x squared minus 2x minus 15, once it focuses here. And I'm dividing it by x minus 5. Okay, so I'm going to leave some room. X minus 5 goes on the outside. And then I get x squared minus 2x minus 15. We have to do a check to make sure that we have all of the exponents in decreasing order. So this guy started out with an x squared, then we have a plain old x, and then we have a constant. So we're good. If we're missing any exponents, we have to add a placeholder. And I'll show you that here in just a second. Alright, so I'm just going to look here at this guy right there, and I'm going to say, okay, what do I have to multiply x by to get x squared? What do I multiply x by to get x squared? Just an x, right? And I'm going to line them up underneath the x's. Just like we did over here, right? We lined up. Oh, geez. I put this 9 above the 6. Okay. Just like we did with long division, I multiplied the guy on top by what's out front. Well, now there's 2 things out front, so I have to multiply it by both. So x times x is x squared. And x times a negative 5 is minus 5x. Okay, then we were doing long division and what do we do with these guys? Subtract it, right? But I think I've told you before, subtraction sucks. So don't subtract, add the opposite. And some of you are going to say, hey, crazy, that's the same thing. Yeah, I know, but it works out a whole lot better if you flip and then add. Flip, flip, add. So I have an x plus a negative x squared, x squared plus a negative x squared. Those guys are going to cancel. And then I have a negative 2x plus 5x. 3x. And just like with our long division, then we brought the next one down. So minus 15. Okay. What do I multiply x by now to get 3x? 3. So I'm going to put a plus 3 on the top. So then I multiply what's new, the 3, by everything out front. Okay, so 3 times x is 3x. 3 times the negative 5 is negative 15. And don't subtract. Flip, flip, and add. What happened to this guy?
0.
0. We got a 0 remainder, right? That means it went in very nicely and evenly. So this guy right here is my solution. Abigail.
Why would when you put the plus x on top, why would it be above the negative x instead of the x squared?
So I'm just lining up the number of exponents is really all I'm doing. So usually it's just 1 over. It doesn't really matter, just as long as, yeah. Like I said, I'm just lining up the number of exponents that he has.
Are we going to have to do that, or can we do that?
What do you mean?
This is the only time in math that we got it.
Dang! You didn't like the long division there? I'm going to show you another method here in a little bit, but we can't always use it. So, there is another way, and it's faster, but we can't always use it. And I'll show you when you can use it and when you have to use it. Most of the time we can use the other method, but there are certain times where we have to use this one. Yeah. Okay. The other thing I want you to notice, this guy right here, that's our like old-fashioned division symbol, right? And this guy right here also means divide. And there, that guy we recognize. What about this dude? Multiply. But, well, hold on, let's think for a second. What do you remember about negative exponents? Turns it into a fraction, right? So this whole thing right here ends up going into the denominator. So this would really be like that, right? Without that there. So this is just a fancy way of writing divide me also. Does that make sense? So you could see it with the old-fashioned, the bar and the 2 dots. You could see it like a fraction bar. You could see it with a negative 1 exponent. Because remember, when it's got a negative exponent, he goes to the denominator. Sound good? Okay, so this guy just means the same thing as divide. Well, let's divide this bad boy. So I want you to look really quick at him first. He's got an x or a y to the 4th. Do I have a y cubed? No. So we're going to have to put in a placeholder. Remember, placeholders just hold the place and they really have a 0 coefficient. Then I have a y squared, and then I have a y, and then I have a constant. So how many placeholders do I need? I have a 4, I don't have a 3, I got a 2, a 1, and a constant. 1, we just need 1. Let me show you. I got 4y to the 4th minus 5y squared. Oh, I screwed it up already. I don't have a 3. I don't have an exponent of 3. It's tape. It's white out tape. It's pretty sweet, huh? So you can think about that guy as with a 1. So I have a 4, a 3, a 2, a 1, and a constant. So I only need one placeholder that has a 0. It'll help you because you'll end up have a constant anyway, so it'll kind of help it keep it in line, JT. So I would say yes. It's not mandatory, but it, like I said, it'll help you keep things lined up. You're welcome. Good question. Okay. What do I multiply 2y by to get 4y to the 4th? Okay, so we know we need 3 y's, right? I have 1, I need a total of 4, so I've got a y to the 3rd, and what do I have to multiply 2 by to get 2? I mean 4. 2, right? So we want 2y to the 3rd. That's better. And so then I just, see how I just put him under the y to the 3rd, Abigail? It's not really that critical. Okay, so I'm going to multiply the guy on top by both things out front. So 2y to the 3rd times 2y gives me 4y to the 4th. 2y to the 3rd times a negative 1 gives me negative 2y cubed. And don't subtract. Flip, flip, add. So the 4y to the 4s are going to cancel, and I'm left with 2y to the 3rd. Bring the next one down. Minus 5y squared. Okay, what do I multiply 2y by to get 2y to the 3rd? Y squared, right? I have a 2, so I don't need a coefficient, so I'm just going to say plus. If you want a 1, you can put a 1. I have 1 y, I need 3, so I need 2 more y's. Okay, multiply the new guy on top by everything out front. So y squared times 2y gives me 2y to the 3rd. Y squared times a negative 1 gives me negative y squared. That first one should always cancel out, okay? You're figuring out what to multiply to make it work, so it should always cancel out. Flip, flip, and add. So, minus 5y squared plus 1y squared gives me a negative 4y squared. Bring the next one down. Okay, so what do you multiply 2y by to get negative 4y squared? negative 2y. Okay? I have 1y. I need 2, so I need 1 more. Okay, multiply the new guy on top by everything out front. Negative 2y times 2y is negative 4. Y squared. Negative 2y times a negative 1 gives me plus 2y. Okay, flip, flip, add them together. Uh-oh, what happened? Everything cancels and I get 0. And I bring the next one down, so I get plus 4. Can I multiply 2y by anything so I just get 4? No, I can't. This guy right here becomes my remainder. So here's how you're going to write your remainder. I'm going to say, he's a positive 4, so I'm going to say plus 4 divided by what I'm divided by, 2y plus 1. So there is your solution. So you take your remainder and put him as a fraction. I guess technically we could have done it on this guy, right? We had 2 left over, so we could have said plus 2/5. Like that. Okay, questions before we try one more? JJ.
I'm gonna like rephrase this as a curious question.
Yeah.
But when will we use this?
Every day of your life, when you're older, especially when you're taking out the trash, you'll think, man, I'm really glad I know how to divide polynomials, right? Yeah. So, I would say as you get further on into math classes, then you'll use it more. Does that make sense? So, this is kind of like our precursor. We're going to start factoring. And then we use those guys to solve them. So eventually where we're going to get in here, and it's not the most perfect math, I'm going to use this in the real world answer, but I'm going to give you something like this guy right here, 6x to the 4th, and we're going to solve it and find all of those solutions to that guy. That's my favorite part. But we may have to divide some a little bit to make it a little bit easier. So we're going to use the back side of this, actually, more than we'll do the long division stuff.
Okay.
Does that make sense? Yeah. It's also because it's torturous, you know? Yeah. Juliet.
So for like when you write the answer,
Yes.
so when you flip the sign, it'll be plus whatever it was that you multiplied by.
Right,
And
so,
if you don't, it's subtraction.
yeah, so see how this guy was positive here? So he's going to stay a positive there. If it was a minus sign, if this guy was negative, we could do a minus sign here, or you could make that 4 negative. Yes, good question. Well then, good. Thanks, dude. Did that answer your question, JJ?
Mostly.
Mostly. I know it's not like the perfect real world, when do we use this type of thing. But honestly, the coolest part is when we get to chapter 7, which probably won't be till second semester. But when we get to chapter 7, we can look at this guy, know how many solutions he has. We can find them all, but we have to make it more simplified to do that. So, just remember, when you get into advanced more math, it's not something that you're going to use like every day in the real world. But you're also learning skills to persevere, keep going, solve problems, you know, that sort of thing. Sound good? Okay. Should we do one more long division one? And then go to the other version? Yeah? Okay. So do you want to do 5 or do you want to do 6? Anybody?
Let's do 6.
5? 5. Okay, we'll do 5. I can show you 6 as well later, okay? Okay, so 5. Look at 5 first before you set it up. Do we need any placeholders? We have an x to the 4th, we have an x to the 3rd, we have an x squared, we have a plain old x, and we have a constant. Do we need any placeholders? Nope, they're all there. Okay, so let's set this guy up. Okay, so we got them all set up. What do I multiply 3x by to get 6x to the 4th?
2x to the 3rd.
Perfect. Multiply the guy on top by both things out front. So 2x to the 3rd times 3x gives me 6x to the 4th. Plus 2x to the 3rd times 1 gives me 2x to the 3rd. And don't subtract. Flip, flip, and add. You force those first ones to cancel, so those 6x to the 4th should cancel. And I have 5x cubed plus negative 2x cubed. So I get 3x cubed. Now, here's another thing. Say we forgot to flip and add, and you forgot, and you're like, okay, well, I have to remember to subtract. But then you forget to subtract, and you got a 7x cubed right there. Is that going to work? Can I multiply 3x by anything to get 7? No. Okay, so be careful. If you end up getting stuck, you've missed adding and subtracting somewhere. All right, bring the next one down so I get plus x squared. Okay, what do you multiply 3x by to get 3x to the 3rd? X squared. Bless you. Okay, multiply the new guy on top by both things out front. So x squared times 3x gives me 3x cubed. X squared times 1x gives me a plus 1x squared. Flip, flip, add. Uh-oh, what happened? They both cancel. That's okay. We're just going to bring down the next two things. Okay, what do I multiply 3x by to get negative 3x? Negative 1. Multiply the new guy on top by both things out front. Negative 3x minus 1. Flip, flip, add. What do you get? 2. So that 2 now is my remainder. He's positive 2, so I'm going to say plus 2 divided by 3x plus 1. And we're all done. Okay, how do you feel about long division?
I don't like it.
No? Not a fan. It's okay. Meh. Right? I wouldn't choose to do it if I were bored and wanted something to do. Right? Okay. I'm going to show you another method, and then I'm going to tell you when you can use both of them. All right, so I think if you turn the page in your notes, it's on the other side. This one, we're going to end up using it a ton. Okay? So, turn the page and let's talk about synthetic division. If you want to see 6 at the end, I'll go back and do 6, okay? So, synthetic division is another way to divide polynomials. The coefficient of your divisor must be 1 to use this method. Okay, what does that mean? The guy that you're dividing by, his coefficient has to be 1. Meaning, see this guy right here, he doesn't have a number in front of the x. And this guy right here doesn't have a number in front of the t. And this guy right here doesn't have a number in front of the x either. That coefficient has to be 1 in order to use synthetic division. Okay? Look back at the long division ones. We could have done it on this guy because his coefficient was 1. We could not have done it here because his coefficient is 2. We could not have done it here because our coefficient is 3. Does that make sense? On your homework, I set it apart too, so I tell you do long divisions on these ones, do synthetic on these ones. Same thing with your test. It'll say long division on these ones, synthetic on these ones, okay? And I give you fewer long divisions to do than synthetics, okay? Now, so these ones, the coefficient there has to be 1. Remember, that means divide. That guy also means divide. That's another way of writing divide. So those are your 3 ways that you're going to see it written with division. Okay? The other thing you're going to do is you also still need to have placeholders. All right? So we're going to check here. This guy has an x cubed, and then I have an x squared, and then I have an x, and then I have a constant. Do I need any placeholders? No, we're good. All right. It's a little tricky to set up the first time, but once we get it set up, then you'll see it. What we're going to do is we're just going to write down the coefficients of the numbers okay, of the terms. So this guy has a 1 out front, and then I've got a -4, and then a 6, and then a -4. So right now he's just a list of numbers, but those are the coefficients of each one of the terms. Okay? Leave a little space because we're going to write some numbers under each one of those, and then I'm going to make a little half box to the left. That little half box to the left is where I need to put another number, but I have to look at my divisor. Okay, my divisor right here is x minus 2. If I were going to set that equal to 0, what would x equal? 2. So essentially, I'm flipping the sign of this guy right here. He was a -2 here, so I'm going to put a +2 in my little half box. Okay, the first thing I always do is I bring down that first number and write him below the line, no matter what he is. This case, it's a 1, it could be a 12, it could be a 4, it could be anything. You always write it below the line. Okay, now I'm going to take the number that's in my box, I'm going to multiply it by the number that's below the line, and I'm going to put it below the next number. So 2 times 1 gives me 2. Then I'm going to add down. -4 plus 2 gives me -2. This one?
Yeah.
No, he's an arrow, sorry. There. Okay, take the number that's in the box, multiply it by the number that's below the line, 2 times a negative 2 gives me a negative 4. Add down. Okay, I'm going to repeat the process. 2 times the new number below the line is 2, which is 4. Add down. Put a box around that last number. That box is my remainder. So this guy worked out nicely, right? We don't have a remainder. That would be like the one on the other side. That guy right there didn't have a remainder, right? He worked out nicely. Okay, now let's look at these guys for a second, because right now all I have is a list of numbers. What the heck, right? Okay, let's look and see what happened. I started out here with an x squared, and I divided an x out, and my answer had an x. I started out with a y to the 4th. I divided it, and my answer started out with a y to the 3rd. I started out with an x to the 4th. I divided, and my answer started out with an x to the 3rd. What's happening to my answer?
The exponents are going down.
The exponent's going down by 1, right? In fact, what we call this guy right here is a depressed polynomial. He's sad. He lost an exponent, okay? So we've depressed his polynomial. He started out with an x to the 3rd. We divided an x out. What's he going to end up with? X to the 2nd. Okay? So if this guy started out with an x to the 3rd, these are the coefficients of my answer. So watch what happens. He started out with an x to the 3rd. I'm going to drop 1. I now have x squared. And then I just write my x's in decreasing order. So I get a minus 2, x to the 1st if you want, plus 2. And that's my answer.
I like that better than what we
Right? It's pretty fast too. Questions before we try another one? Okay, let's try another one. The trick is you have to have placeholders. If you don't have placeholders, you're going to mess up. Okay, so look at number 8. I have t cubed minus 6t squared plus 1. Do I need a placeholder? Yes, I need a 0, right? So I'm going to rewrite it. So I have t to the 3rd minus 6t squared plus 0t plus 1. Write your coefficients down. 1, negative 6, 0, 1. Little box to the left. If you want to put your remainder box there, you can start there. Okay, we were dividing by x minus 2, and I put a positive 2 in the box. Now we're dividing by t plus 2. What am I going to put in the box here? Flip it. Think about t plus 2 equals 0, so t equals negative 2. Okay, bring that first one down below the line. No matter what he is, this guy's a 1. Multiply. Box times below the line. Negative 2 times 1. Negative 2. Add down. Negative 6 plus a negative 2. Negative 8. Negative 2 times a negative 8. Positive 16. Add down. 0 plus 16 is 16. 16 times a negative 2. Negative 32. Add down. Ooh, I didn't make my box beat. Oh, there it is. Negative 31. Okay, so I started out with a t to the third. What's my answer going to have? T to the second. And I'm going to use these guys as my coefficient. So 1, t to the second, minus 8, drop it another t, plus 16. Now, this guy's now a negative 31. So there's two ways you can do it. You can say plus a negative 31, or you can say minus 31 divided by t plus 2. So we're going to write the remainder the same way that we do it with long division. What do you think? Better? Sometimes the numbers get big because you're multiplying and adding and multiplying and adding and multiplying and adding. And that's okay. Sometimes the numbers are big and that's okay. Let's go ahead and do the last one there. So look at it and how many placeholders do I need? Thank you. I have an x to the 5th. Do I have an x to the 4th? No. Do I have an x to the 3rd? Do I have an x squared? No. Okay, so I'm going to start it and then I want you to see if you can finish it. So I have x to the 5th plus 0x to the 4th minus 7x cubed plus 0x squared plus 1x plus 1. 1, 0, negative 7, 0, 1, 1. What's going to go in my little box? Negative 3, right? I'm dividing by x plus 3, so I'm going to put a negative 3. Okay, bring the first one down. Negative 3 times 1. Negative 3. Add down. Okay, see if you can finish it. Yes, if you need a calculator. about these? Because I can just check your remaining. And just like with chapter 3, if you miss a sign, it makes things more difficult. Okay, so I'm going to finish it so you can see it. Add down, I get -3. -3 times a -3 is +9. Add down, I get 2. -3 times 2 is -6. Add down, -6 plus 0 is -6. -3 times a -6 is 18. Add down is 19. 19 times a -3 is -57. Plus 1 would be -56. Okay, so this guy started out with an x to the 5th. Drop 1 down, so he's 1. X to the 4th. Minus 3, x, drop 1 to the 3rd. Plus 2, x squared. Minus 6x. Plus 19. Minus 56 over x plus 3. Okay, how do you feel? Yeah? You're okay with those ones? Okay, let's go take a look at your homework. So turn the page a couple. So number 1 and number 2 are just like the very first two ones on your notes. So you can just separate it and divide each one. Okay? Simplify each term. So you're going to take 18a cubed divided by 3a and 30a squared divided by 3a. Okay? For 3 through 8, those ones you're doing long division. And if you notice, they all have a coefficient in front of the divisor that's bigger than 1. So you've got to use your long division there. Okay? The back side is all synthetic. Okay? So, you have a total of 18 to do. I will let you get cruising. Sound good? Okay. Did somebody want to see number 6 on the notes?